to our ASCE YouTube channel, which you can find on our website. So if you miss anything, you want to go back and check, or if one of your friends wanted to jump into one of these meetings and they didn't get the chance to, they can check them out there. Otherwise, welcome to our third ASCE General Body meeting for the spring 2021 semester. I've pushed this 100 times. I'm going to do it again. Can't stop me. National registration is so important for ASCE. It's not just us. It's not me sitting here at my computer talking to you. That's not all ASCE is. There is a network of working professionals behind this organization. There's many layers above us that are working to support you once you graduate. So registering nationally is really important to have access to that now and in the future. So for students, it's free. It costs a certain amount of money that luckily I don't have to pay yet since I'm still a student. But for right now, you can get all the benefits that working professionals get by being a national member for free as a student. It only takes a few minutes to sign up, and it's at that link below, asce.org/membership/student. I think at our fourth general body meeting, we'd like to take less than 10 minutes, because that's how quick it is, to walk you guys through registering live here on Zoom with this screen sharing. Makes it really easy. Everybody's on their own personal device. They can watch the meeting and play along at home. So watch out for that at the beginning of our fourth meeting. We'll maybe walk you guys through that. It's not too hard. So, little update on our ASCE officers. This is the current list, but it's now become outdated. Our recruiter position is no longer available because Mazen has stepped in as our recruiter for the rest of this semester and fall semester of 2021. So thanks to Mazen for stepping up, and welcome to the ASCE Officer Board. We're happy to have you here. An update on t-shirts. They're now going to be able, you can purchase one if you haven't already. So this is not just for people who ordered them before winter break. This is for anyone who wants one. You're just going to be able to walk up, Venmo our group account, OSU_ASCE, and grab whichever t-shirt suits your fancy. So the first pickup is going to be Friday from noon to 1. That's just a little teaser. I'm going to send out an email this week with every time that's coming up soon. It's going to be one this week, like I said, Friday noon to 1, but then there's going to be a couple next week that I haven't exactly decided on. But it's going to be really easy, you guys. Nothing complicated like last time. No order form, no pickup windows or anything like that. It's just going to be walk up, pay us, grab a t-shirt, and go, just like it should be for any regular semester. So get excited. If you've been waiting on a t-shirt, now's your time. And I'd just like to add that if you did order one, there's a few names here. I'm going to read them off in case you're present or you know these people. Let them know that this is happening, because the people who ordered ahead that didn't get their t-shirt, that have already paid for one and I have ready for pickup, are Jack Bush, Aaron Bauman, Dawn Mergay, John Bosworth, and Kushi Garg. So if you know any of them, just let them know we're ready and waiting to give them their t-shirt. Okay, upcoming opportunities. That should be upcoming opportunity, because there's only one this week. But we've got a Diversity in Water series. This month, it's the Women in Water section of the Diversity in Water series, because March is National Women's Month. So they've got LaQuania Graham. I have the details here on my left screen. Let's see. Because it's a long title, the Education and Outreach Administrator for the City of Cleveland. And she's also an author. So if you'd like to hear from her, there's more details in this on the email that I sent out on Sunday. It'll be in the email this week on this Sunday, but the link that QR code goes to register is also there. That's on March 18th at 5:30 p.m. So that's next Thursday. That sounds interesting to you. It's hosted by those two committees down at the bottom. Okay, I told you that my introduction this week would be short, and it is, because it's time to introduce our guest speakers. Nick Brady and Gina Balsamo. They are representing ITE this month. They're always representing ITE, but for us, they're representing it this month, and we're excited to hear them speak. So Nick and Gina, take it away. I apologize.
Okay, let's see. Can you guys see my screen?
Yeah, that looks great.
Yep, you're good.
Yep, so I'm Gina Balsamo. I went to the University of Dayton. Sorry, guys, I didn't go to Ohio State. And I'm going to be presenting on safety studies and traffic impact studies. And then Nick Brady will be presenting after me. He went to Ohio University. He got a bachelor's and a master's there, and he will be presenting on traffic design. And Nick works at EMH&T, and I work at Carpenter Marty Transportation. And just some fun facts, Nick and I actually used to work together back at Carpenter Marty. So he left us for a different company. No hard feelings. So first of all, traffic studies. We're going to be talking about access and impact studies and then safety studies after that. So for access studies, they're generally the smaller type of impact studies. So you have a development, and let's say it's a Kroger. You need to do a study to tell the developer what they need to pay for. Like, do they need a traffic signal? Do they need to add turn lanes? Things like that. So an access study is generally just looking at those specific access points. So you're looking at turn lane warrants, site distance analysis, just smaller things like that. Whereas an impact study is a lot larger of an area. You're going to be looking at the adjacent intersections in addition to just those access points. And the national consensus is that if your development has over 100 peak hour trips, then you're going to trigger the need for an impact study. Okay, and then here's kind of an idea of how those peak hour trips, how they get larger, and then how that triggers a larger study as well. So, 0 to 100 peak hour trips are just site drives, whereas 100 to 200, you start getting into intersections and so on. It starts getting into a larger and larger study based on the size of the development. Okay, and then some of the other basics, once you get a developer will come to you and they generally have no idea what a traffic study is. They don't know anything about it. So you're there to tell them what they need, what you have to do. So you kind of decide based on the size, is it going to be an impact study or an access study? And then you kind of look at the surrounding area too, like, are there other developments that are happening nearby that we need to consider as well? You decide on your opening year and your design year. So you don't want to just design your turn lanes for what's going to be there right now. You want to look with growth rates surrounding the area. You might need more turn lanes later, whereas opposed to now, you may not need them. You also have to do data collection, so turning movement counts, things like that. And usually we just do the AM and PM peak hours, but sometimes you might need a lunch hour, or you might also need to do like the school afternoon peak hour. Something like that could get added in just based on the site needs and what's in the surrounding area. You also have to look into the agencies involved. So, if your development is in one city, then obviously that city is going to be a reviewer. But sometimes you have the site is one city, but then the nearby intersections are the county or another city. So sometimes you can get multiple agencies involved. And then after that, you submit the study, they review it, give you comments, and then you revise and go back again. So then you also do some trip generation and figure out how to distribute that traffic. So let's use the example of the Kroger. You determine how many trips that Kroger needs. And that's based on the land use. You have your grocery store, you have a bank or something like that involved. And let's say you have a Kroger next to a bank. You may be able to have some internal capture reductions because you might have somebody who's going to pick up their groceries and going to the bank in the same exact trip. So you won't need to double those trips. You can have some reduction based on that. Or, if there's transit around, there could be reductions based on that. there's also different types of trips. So you could have your trips that are people just going to the grocery store and going back home. But then you could have somebody who's driving to stop at the grocery store on their way home from work and then continuing on the same path. So you have different types of trips that you have to look at. And then, like I said before, you're looking at not just your development, but also developments in the area and how that impacts the improvements you may need. You look at the distribution of those trips. So it's not just, 100 trips going in and out of the Kroger. You have to figure out where those trips are going from each site drive. Are they going to the north or the south? Where do you think those trips are going to and coming from? And then the background growth rate, because you have your development and you have other known developments, but then there's a lot of growth going on outside of that. So typically we look at historical count data, see how the counts have grown over the years. And then we also will contact MORPC, which is the local MPO, and they'll give you a general growth rate as well, although they'll take weeks to give it to you. So sometimes it's easier to do that on your own. And then here's just an example of if you're doing trip generation, here's kind of what the output looks like. So let's say you have an apartment and you define the size, and then it will output, your entry and exit trips during each peak. So you have your AM peak, your PM peak, and your weekday peak. And then it does that for all these different land uses you could put in there. And basically all you do is just, you tell it the size and then it spits out the trips for you. And then you take that information and you do capacity analysis here on the right. It shows you the control delay, the level of service, things like that. And then you can, the city will tell you, we don't want to exceed a level of service D. So that way you need to recommend improvements that bring the level of service back to what they consider is acceptable. And then you have turn lane warrants over here. So there's a certain number of turning movement volume that will trigger the need for a turn lane. So there's graphs that you use to tell them, if you trigger that or not. Okay, so basically with an impact study and access study, they're both just telling you what things are like now, what they're going to be like in the future, and then what they're going to be like after the development is over. Basically, so they can just pin those improvements on the developer and the city doesn't have to pay for all of that. And, after we do the analysis, you just look at it stage by stage in your existing no build and build conditions and see what improvements are needed for each scenario. And then recommend solutions after that, bundle it all up in a report and go from there. Okay, then next I'm talking about safety studies, which is my personal favorite topic. So each year ODOT prioritizes their roadway segments and intersections throughout the whole state. And they basically choose which intersections they want to study. And they do that by looking at crash statistics and identifying those locations with the highest potential for reducing crashes. So they look at the expected average crash frequency and compare that to the predicted average crash frequency, which is basically just based on the type of site, how it compares to its peers, and then that determines if that site has a potential for safety improvement, like if it's worth making those improvements. So here's just a map of those locations, and this is kind of old too, but you can see like generally there's big groupings of these intersections and segments where the big cities are. So Cincinnati, Columbus, Cleveland, Toledo. That's where all our high crash intersections are, some sprinkled throughout as well. And then we study those sites and then we tell them if they need to make safety improvements and what those improvements would be. Oh, and then I just snipped this out for fun. Here's some locations around Ohio State, some 23 and Fifth Avenue. And then these are just ones on the interstate too. Okay, so then some key elements of a safety study, first we just look at the existing conditions. Sometimes just by doing a site visit, you can immediately tell what the issues are. And then we look at the crash analysis, the capacity analysis, and then we start developing countermeasures, and then we do a benefit cost analysis, which I'll go through. So when you're looking at the existing conditions, you're looking at things like the land use, like what's the surrounding area like? Like this area, you can see there's a lot of developments around it, a lot of access points. You look at the roadway conditions. Is there a lot of pavement rutting? Things like that. Intersection conditions. How does the signal operate? Is it stop controlled? You look at the clearance intervals, the traffic counts, and then you do capacity analysis, because sometimes you'll find out that there are crashes just because of the fact that drivers are frustrated and they can't get through the intersection. So they're trying to push that yellow, which can cause crashes. So then we do a crash analysis. So basically, whenever you're in a crash, if you've been in one before, you might know this, but the police officer fills out this report that you see on the right. So that report then goes in a database that we get to look at. So that's part of our job, is literally going through crash report by crash report for each crash and reading what that officer put. And it gives a description line by line of what happened. Sometimes it's more descriptive, sometimes it's not. You run across some really funny ones, though, I will say, over the years. But so basically you review all that data, you analyze it, and then you come up with this crash diagram, which helps to show trends in the crashes. So you can see, like, over here, there's a lot of left turn crashes. Over here, there's a lot of rear end crashes on this approach, and a lot of angle crashes here at these site drives, because I don't know why this gas station decided they needed 4 different access points. It's a little redundant, just adds more conflict points. So then after you do all of that, you start developing your countermeasures. So you can see, like what I said before, we have these access drives. They don't need all these access points. So we recommended closing one off and then also adding quick curb over here, which are basically those like raised bollards you'll see on the yellow line. That can just prevent people from turning left into the site drive or left out of the site drive, because that's just a cause for a crash. You're turning through the queue, you can't see what's going on. You may have some good Samaritan who waves you on to go, but they don't know that there's somebody else coming behind you who's gonna hit them. And then, we may make some little recommendations like signage, or adding some signal upgrades, pavement marking upgrades. The changes could be smaller or larger, and usually we do make those like low cost, quick fix recommendations. So that way, if they want to do something really quick, they can, while they're waiting for their roundabout to be designed, 3 years down the road. Okay, and then after you decide what you want to do, you make a cost estimate for that. So like, what's it going to cost ODOT to implement a roundabout at this intersection? And then they have this database that basically tells you how many crashes they expect that to mitigate. And it's sad, but they put a number, like a price, on those crashes. So injuries, fatalities, just minor fender benders, everything. They have a crash cost associated with that. So then you're comparing the cost of that roundabout improvement to the benefit of reducing those crashes, and then you come up with this benefit cost ratio. And so that tells you, is your project that you're proposing worth the investment? And I will say, it's not always straightforward. There are so many times where there's projects where we have a benefit cost ratio that's less than 1, but just using engineering judgment, that it's a good recommendation and that it's going to mitigate crashes. So it's not the end all be all. Okay, so I have this, but I don't know if you want to take questions now or kick it to Nick and take questions at the end.
We can do both. You combine unless anybody has a burning question they want to ask just right now. Cool, then we'll kick it to Nick.
All right, we'll keep going. All right, can you see the screen?
Yeah, that looks great.
Perfect. So Gina covered the traffic planning side of what we typically encounter on a regular basis. I'm going to go through the different traffic engineering design components that traffic engineers with our companies would handle. So at both Carpenter Marty and EMH&T, we'll cover both sides of traffic engineering. So we'll do both the planning as well as the design work for various projects. So I'll go through what we typically encounter in the design as traffic engineers. Generally, what we're looking at are what I like to call like the finishing touches for a roadway design. So you can see the bullet points here. This is what I'll touch on briefly throughout the design presentation. But items like the traffic signals or the pavement markings, as a traffic engineer, we'll handle what happens after the roadway has already been designed. The roadway engineers, they'll determine grades, curves, things like that. We'll come through and then put these items in then to help make it functional, and we'll go from there to create a complete roadway. So like Gina said, she likes to focus predominantly on the planning and the safety studies. My preference in traffic engineering is the design work. There's a lot of similarities as far as reviews, agency input, coordination between the two, but I tend to like the design and actually putting together the construction plans. And these are the steps that come after the planning portion is completed. Then we'll go through this process to actually turn the planning into a project. So the first item I wanted to touch on was traffic signal design. So you've probably seen examples of both of these types, either around campus or wherever you're from, your local hometowns, or just driving around. So the two general types of traffic signals we'll put in are span wire or mast arm. So it's pretty self-explanatory. The one on the left here is a span wire. The one on the right is a mast arm. So you can see the span wire signals generally save a little bit of cost. And one advantage to them is you can span a lot larger roadways. So if you've driven kind of in the Polaris area or anywhere with a really large multi-lane roadway, sometimes you'll see these just because the mast arm is limited. You can't have a 100-foot arm, 150-foot arm. It starts to get a little impractical. So sometimes span wire is preferred in those cases. And then with the mast arms, as you can see, they cost a little bit to quite a bit more. But a lot of times we'll work with agencies and they'll prefer these over the span wire just to fit their streetscape. So making sure they have like a coordinated color scheme. The decorative poles match their light poles. So the mast arms can provide a little bit better looking traffic signal. Agencies, especially the cities, like that a little bit more. And additionally, they provide a little bit better visibility. So as a driver, when you approach a mast arm, it tends to stand out a little bit better as you approach an intersection. So from like a safety aspect, sometimes that can help a little bit over a span wire. Drivers are more likely to notice an object, especially if they haven't driven through a signal or it's been a long stretch. It can tend to make the visibility a little bit better. So there's definitely pros and cons to both. And then as traffic engineers, depending on the agency preference, depending on what the project calls for, we'll design one or the other. So we encounter both of these on a pretty regular basis. Another item that goes along with the traffic signals, we'll actually design vehicle detection and we'll place the vehicle detection locations. So you've probably seen this image on the top right here is what used to be the standard go-to and still is used quite a bit depending on the situation. These are just loop detectors. They're inductive loops that can sense a car parked on top of them. So you still see these all over the place. Some additional technologies have come out I say recently, but it's probably 10, 15 years. They've been out for a while now, so it's really not that recent anymore. The item on the left, so some agencies will actually use video cameras for the detection. They'll set up zones within the camera, and it actually takes an image. It's constantly monitoring the intersection, and it can sense when a vehicle is there. And with any of these types of detection, once it senses a vehicle, it'll start a sequence then to change from red to green. It'll start that process. So then it'll call the green phase, and then you're able to pass through the intersection. So one of the newer systems is video detection. And then the bottom right here is radar detection. So this has become the preference for a lot of agencies. With video detection, sometimes weather plays a factor in how well it can function. If you have a rainy day or if you have ice on the lens, sometimes it prohibits it from actually seeing the vehicles and can cause issues. Radar doesn't necessarily have those same limitations. With the loop detectors, so when they're cutting the ground, sometimes you get issues with cables deteriorating. If the pavement shifts, sometimes it can break the cables and cause issues there. So none of these are completely 100% foolproof, but in general, we've seen a lot of the agencies are starting to move to radar detection just to ensure better detection and more reliable detection at intersections, help the traffic flow and help the operations work a little bit more efficiently. So this is just a sample traffic signal plan. It's probably super tiny on your screen, so not really much to show here other than just showing you guys what a typical traffic signal plan would look like. So as a traffic design engineer for signals, we'll actually lay out pole locations, we'll lay out all the different equipment needed to make the signal function. We'll also lay out pretty simple diagrams, but we'll lay out wiring diagrams as well, which tells the contractor how to actually wire up the signal in the way we want. So it goes a little bit beyond just placing physical items. We'll actually get into some of the wiring diagrams as well as telling the contractor the traffic signal timing. So how long the yellow should last, how long the green time should last for each direction and things like that. So that's just a sample traffic signal plan there. In addition to the traffic signals for vehicles, we'll also design pedestrian traffic signals as well. So these are for roadways that don't necessarily need a traffic signal, or for crosswalks like mid-block crossings. So not necessarily at a major intersection, we'll design these. So on the right is an example of a rectangular rapid flashing beacon, or RFB. You've probably seen those around campus at some of the busier crosswalks. And then on the left is a little more robust structure. So we call these pedestrian hybrid beacons. They used to be called Hawk signals. I know Gina's a big fan of that name. But it's a pedestrian hybrid beacon. So essentially these function, they're slightly less involved than a full traffic signal, and they're more appropriate for pedestrian crossings. So when you have a crosswalk, maybe you're getting poor compliance for vehicles stopping for pedestrians, or you just have a lot of pedestrian traffic, these can be used there to help facilitate that crossing and help make drivers aware that this is where the pedestrian crossing is. So I focus predominantly on traffic signal design. So I'm going to touch on some other aspects of design that I have a little bit less experience in, but just to give you a background and show you kind of the broad range of what we cover. Highway lighting is something at least I didn't know graduating college that a traffic engineer handled, but I guess it kind of goes hand in hand with the signals and the wiring that we do for those. So we'll actually design and place street lighting for various facilities. So it can range anything. So on the left, we have just a decorative pole for like a low volume, low speed roadway, like a residential street. And then all the way on the right is just a sample. You've probably seen those everywhere for freeway lighting, the high mast supports for the lighting, and then pretty much anything in between. So highway lighting is something that the traffic engineering design department will handle as part of the roadway design process and putting together the plans. So in addition to deciding what type of poles we'll place, we'll also actually physically locate the poles. We'll do some analyses called photometric analysis. It helps us figure out where to put the poles, pole height, spacing, It's dependent on the type of illumination that we select. And then each agency has different requirements. So depending on where you actually place, the poles, there's different brightness requirements. They also have average illumination requirements. So you don't want somebody driving into light spots, into dark spots, into light spots. You want the roadway to be lit pretty uniformly. So we'll actually decide based on the agency requirements where to place poles and determine what luminaires to use based on their types of requirements. And that can range anywhere from the freeways down to just basic parking lot lighting or pedestrian crossing lighting. And again, so kind of like the traffic signals, is just a sample plan sheet. We'll actually show the wiring, we'll show placement of the different items to make a street lighting plan work. So this is Cleveland Avenue and Schrock Road. I pulled quite a few sheets from that plan, but this just shows just a sample lighting plan for reference. In addition to that, we'll also document the any decorative items that an agency might want. So again, that's all part of the traffic signal plan. We'll cover that for the agencies as well and make sure that's included in the plans. Maintenance of traffic is another component of what we do. So believe it or not, a lot of the work zones are actually designed. So sometimes it looks like kind of a mess, and sometimes we're really limited on what we can do. So the top right is down on kind of the 315, 71 area south of town. Tons of traffic volume, tons of different phases for MOT. So switching where the lanes are, where they aren't facilitating the construction. It can get pretty challenging to lay it out, maintain the number of lanes that an agency requires, and also allow the contractor to build whatever they're designing. So kind of like the highway lighting and the traffic signals, maintenance of traffic, it's kind of a catch-all. So we're designing pavement marking placement. We're designing the actual barrier locations. The bottom right shows this wood pole, if you can see it. We'll actually look at temporary locations for traffic signals. So it's not a full traffic signal design, but we'll actually place temporary poles, and sometimes even full temporary traffic signals will get designed as part of our MOT requirements. So this shows a sample MOT sheet. So the shading on this particular sheet would show where the contractor would be working during this phase. So again, this is Cleveland Avenue and Schrock. So this is a fairly busy area. If you're not familiar, kind of on the north end of town, north of Columbus. So tons of traffic volume coming through here on a daily basis. And this lays out the different requirements, any modifications to signage, pavement markings, if they need to place. So you can see some portable barrier in this sheet. Some of the signs might not be applicable to this layout, so you have to make sure you pull those out. You're not sending confusing messages to drivers. So a lot actually goes into planning the work zones to make sure that it can accommodate the traffic volume and provide a safe working environment for the contractor to build whatever the project is. And then same thing here, this is just a sample sheet showing a traffic signal plan. So even if this were to be a temporary traffic signal, it still has to function like a regular traffic signal. So the city of Columbus and some other agencies will actually require full designs of these. They require the traffic engineer to put together a full design to make sure it meets their standards, and it's going to allow for efficient operations and make sure vehicles can get through the intersections. So kind of like I touched on with the MOT, we'll actually do the permit signing and pavement markings as well. So that's pretty self-explanatory. It's just the roadway markings and the signs that go with it. And this can range anywhere. On the left, we have an urban street with bicycle markings. We've got crosswalks, and then anywhere from just the more basic urban layouts to what we have on the right is the roundabout up in the Dublin area. It's the 3-lane roundabout. If anybody's driven through that, this is one of the approaches up that way. And then the freeway signing. So you've seen the big overhead signs, the typical freeway markings. So like the other aspects, like the traffic signals, the pedestrian crossings, the lighting, this ranges all sorts of scales from small local roadways all the way up to major freeways and major projects like the roundabout. And for this type of design, so the signing and markings, there's very specific spacing and guidelines that go with these. A lot of agencies have their own requirements. There's different sign requirements, sign sizes, So it can get a lot more complex than just kind of throwing down some paint and calling it a day. A lot of these items are planned out to make sure that it's creating a uniform environment, making sure that if you see this somewhere, you know what to do, you know what the signs mean. So this is just a sample sheet showing the different signage, maybe items are to be removed, and then what type of lines and what type of paint material that a contractor would use to make this happen. And then the final item that I'm going to touch on is just quickly cover roundabout design. So the top right is that 3-lane roundabout up near Dublin, just an aerial view of that. And then on the left, this is kind of down near the Hocking Hills area, but roundabouts can be placed pretty much anywhere, depending on the type of use, depending on what, say, Gina would find in the capacity analysis and the planning process. They can be used in a lot of different situations, from huge urban areas to interchanges. You've probably driven through plenty around here. So roundabouts are an item that we will design, and there's a lot of different checks that go into it. So it's not quite as easy as just throwing a circle down and making sure the roadway ties in. We'll look and make sure the curves are slowing people down on entry. So that's what the diagram on the left is showing. And we'll also make sure that large vehicles, such as semi trucks, can make it through the roundabout. That's part of the design checks as well. So cars, it's pretty easy to design for, but the larger vehicles, we want to make sure the roundabout can accommodate that. Nobody's going to get stuck in the roundabout. So you've probably seen the different agencies handle this different ways, but this center section will usually have some kind of brick or pavers or pavement inside with like a mountable curb around it. So that's just to facilitate the truck movements. The trailer can off track onto that and make sure that the semi truck can get through the roundabout without causing any issues, running in the grass or getting stuck as it goes through. Then same thing, this is just kind of tying it all together. So in the roundabout design, we'll do the actual design layout, the angles that the roadways are going to tie in. We'll do our checks, make sure that the design vehicles like the semi truck can make it through, and then we'll lay out all the different markings. Some of these are specific to roundabouts. And then you've probably, like, if you've driven through the roundabouts, you've seen all of these various types of markings. You got your yield lines, you'd have approach signage. So we'll actually lay that out as well as part of the roundabout design. So that covers the traffic engineering design component of what we do. If anybody has questions, like it's either on the planning or the design side, feel free to ask, and Gina and I will answer them for you.
I have a question. So with like autonomous vehicles coming into becoming more common, do you see that that'll increase the amount of work for traffic engineers, or do you think that'll decrease the amount of work for traffic engineers?
That is a great question. At least, I guess this isn't necessarily based on any professional experience that I've encountered at the job, but I think depending how the vehicles are set up, and especially that transition phase, I think it's going to be important for traffic engineers to be involved and aware of the capabilities of the vehicles, especially if we're having a transition period where the vehicles aren't quite fully autonomous and we still have people on the road actually physically driving cars. I think up until we go fully autonomous, if we ever get to that stage, but the crossover phase especially, I think it'll take a lot of work and a lot of coordination with traffic design to make sure everybody can use the road together.
Yeah, I agree. I think our jobs will just kind of slowly pivot as things change, and we'll just change with it.
Guys, any other questions for Nick and Gina? Okay. Going once, going twice, and sold. I've got a few things to say just to close us out here. It was cool to see a lot of pictures from around the local area. That's not something that we seen these presentations a lot, I was recognizing quite a few places, especially that roundabout up near Bridge Park. That's very iconic because it's got so many. It's got like the crazy slip lane and everything. So that was cool. That lighting spreadsheet where it like had the pluses and minuses of like, I guess that was like based on ambient light. It was the plus and minus. That was neat. And Gina, seeing a diagram of where the accidents happened, but not only that, like what kind of accident it was. I just didn't expect to see something like that. Like, of course, you think that we're going to track accidents at an intersection, but to see them diagrammed, so it really gives a comprehensive view of where the danger is, right?
Yeah.
So that was cool. You guys sort of gave an overview from Nick's point of view from the design perspective, and then Gina comes in afterwards and goes, here's all the things that are going wrong with it. Here's, you know, here's the changes we need to make. But it was cool to see sort of both halves of that happening at once. So thank you guys. So, we really appreciated your presentation, and thanks for coming in.
Sure. Thanks for having us.
Yeah, no problem.
Awesome. So thanks everybody. Thank you to Nick and Gina for their presentation, but thank you guys for your attention. Our next journal body meeting is Wednesday, April 7th. That's all I've got for you. And officers, I don't need you to stick around tonight. You're free to go. I have nothing for you. So I'll hang around if anybody has something for me. But other than that, enjoy your night, guys. Thanks.
Great. Thank you, guys.
Thank you, Nick and Gina.
Thank you, guys.
Thank you.
No problem.
Bye, everyone.